So we're going to do all kinds of nonlinear regressions today. Does anybody know which ones we've already done? Anybody remember? We did linear regressions the beginning of the year, like the second or third day. But then we did quadratic, we did cubic, we did exponential and power, which look a lot the same. Do you remember we explored all those different places under the regression menu, which was stat, right arrow, and there was all these things, quadratic, cubic, quartic, and we did power or exponential. Okay, today we're going to look at a couple more. This is just a quick reminder that everything is expiring next Tuesday from Chapter 2. I printed you out a list of things you should be retaking. I have a Newton's Law of Cooling and a question off the quiz. I'm going to save those and see what we have time for today. So this is the idea. We've done some exponential growth, and we've even used, I think, the exponential regression. Does that sound familiar? Does anybody remember doing that one? Maybe? Okay, we're going to do logarithmic functions today, and that's when they are growing, but they're growing more slowly. Okay? Or logarithmic decay would be decaying, but decaying more slowly. All right, this is example 1 that you have on worksheet 13, I'm guessing? Yes? Okay, we're supposed to type this in, but what's the first thing students forget to do? When it says X equals year since 1950, I don't want to type 1950, right? Or type 0, 10, 20, 30, 40, and 50 in this case. Okay, how do we get there? Stat, enter to edit our lists, and in list 1 and list 2,
0.
Yep. Everybody good? List 2, I'm going to proof mine because I didn't. 1777, 2502, 3772, 5162, 7113, 9817. I think I have them right. Okay, then we're supposed to be able to look at the stat plot. How do we do that? Or the scatter plot. Okay, second y equals, good call, then what? Okay, turn plot 1 on. We are choosing the first one here, just the dots, and make sure it says list 1 and list 2. And then what do we have to do to get it to actually show up? You may want to go into your y equals and make sure you don't have anything typed in there either. But then we need to do a zoom stat, which is zoom 9. Okay, so everybody do that. Tell me if you're getting this or not. Anybody not getting it to graph? Oh, it's under second format, background. I didn't know there were so many. Is there none as a choice? Just white? How do you select that? All right, I'll have to mess with it later. Several different modes are messed up. Somebody played with it. All right. So what do we think is going on here? Some kind of growth, okay? exponential growth. Normally for exponential growth, if you put in a 0 for something that's growing like this, you'd have a b to the 0, which would make this 1, yes? Does it look like it might go through 0, 1? Or some facsimile of that? Okay, so we're going to, it says, find a function to model. We picked exponential growth, appears to be rising. So with the diagnostic feature turned on, it says, okay, do you remember how to do that? If you have an old calculator, you have to go second 0 and trace all the way down until you see diagnostics on. If you have a newer calculator, you just have to go to mode and make sure down here it says stat diagnostics on. Does everybody have that turned on? It's mode. And then down here, it's stat diagnostics on. You may need to go down and turn it on if it's not. Everybody good? All right, so we're going to try stat. Right arrow. We said exponential, which is on the next screen. It's choice 0 here. And I would like to practice saving. You remember how to do that? List 1, list 2, we don't want a frequency list. We are going to store it. Yeah, alpha trace will work. I'll do it the old way. It's vars, arrow to the right, enter, 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 which is next to clear. All right, otherwise it's alpha trace, and that will give you the choices. All right, if I hit enter, I get this. Anybody else getting this? Since I stored it, I could also look at the graph, and it's doing a nice job of hitting all of those points. So it seems to have a really good fit. All right, the equation we came up with was here. Ugh. There we go. So we have y equals 1812 times 1.039 to the x, if I round. Okay. The r is very close to 1.999, so it's a good fit. If this is an exponential growth, though, can you tell me what the growth rate is? What's your little reference sheet say the formula is for exponential growth, guys? It says original times 1 plus or minus some rate. Does that look familiar on your little reference sheet? So what is this? What? Yeah. 1 plus 0.039, right? Everybody good? Yes. Yeah, thanks. Totally right. 0.03, oh, 0.35 or 49. Yeah, I don't know what I was doing. Let's just go that. Thank you for fixing me. So the growth rate is 0.035 or 3.5% if we move the decimal over twice. All right, let me look back at this just so we can put some context to this question. It says, use the data in the table below to determine a regression equation that best relates the gross domestic product for years since 1950. So it has been growing over this time frame anyway by roughly 3.5%. Okay. All right. Oh, we were supposed to write that here. What was it, guys? 1812. wasn't on the right screen apparently. 1.035 to the x. Estimate the 2020. Okay. How do we estimate 2020? Can we go to the table? And it would be how many years past 1950? Okay. So if you have saved the equation, you could look at the table. Anybody get that number? 1995 1. There's another way you could do that. Remember, you could set it to ask auto. That's under second window, because then you would be able to just type in 70. You wouldn't have to scroll around. So our guess for this, I already forgot, 19,951. All right. I have some more examples here. We used this yesterday, this logistic growth, okay? Logistic growth function says exponential and logarithmic growth are unrestricted. They increase forever with no upper bound. In many growth situations, however, the amount of growth is limited by factors that sustain the population, such as space, food, water. Such factors cause growth that was initially exponential to slow down and level out, approaching a horizontal asymptote. This is called a logistic growth function, and it models such resource-limited exponential growth. So things will grow quickly and then slow down and approach a limit. It has, that limit is called the carrying capacity. I'm not going to quiz you on that, but I find it kind of interesting. And the carrying capacity is generally this number C up on top. It says C is also called the carrying capacity, or kind of the maximum capacity for the population in that area. All right, so we have this example. Can you put, this is the data shows the number of mice living in a certain habitat. So can you put these in real quick? Remember, it's up arrow, clear, enter to clear out a list. Do not delete your list. If you deleted a list, let me know. While you're at it, you might want to clear out your equation in y equals 0, 1, 2, 3, 4, 5, 6, 7. Did I do that one right? And then I have 3, 4, 5.5, 6.6, 7.5, 8.3, 9.1, 9.3. Looks like I got them right. Okay, what do we want to do next? Yeah, we want to look at it. So second y equals, my plot is still on. I do need to adjust mine because I have changed the lists. You should not need to. If you put them in, I have mine in 3 and 4, I think. So I do need, everybody needs to do a new Zoom 9. Does that look like it was growing pretty quickly and then it started to level off? Okay. So it says make a scatter plot of the data, so you need to do that. And it look like that. Mine's very rough. Find a logistic function to model the data. Notice it tells you exactly what function to use. Okay. It is logistic, and that is what it will say. How do we get there again, guys? Stat, right arrow, and it is none of these, including this one that says log or ln. Okay, Don't get all confused. It's way down there. It is called logistic. The whole word is written out. Find it? It's choice B. Okay. Yours are in list 1 and list 2, but mine are in list 3 and 4. And I want to store it again. If you didn't delete the old one, just store it right over the top. Okay. Again, it's vars, arrow to the right, enter, enter, but it's also, remember the shortcut, alpha, trace, enter. Then if I calculate, this one sometimes, now mine was pretty fast. Did yours take a while to calculate this, anybody? This is really slow. What else do you notice? There's a lot of variables, right? We got to put in an A, B, and a C, and the equation itself has an E. There's no R. Okay, there is no way to calculate a correlation coefficient for this. There is a way to test if this is the best fit, but it's very painful. So we're just going to tell you which one to use on the quiz, okay? You don't have to guess and test them. So this equation, let me save this to here so we can try to figure out how to write that. What does it say? It says y equals c over 1 plus a e to the opposite of bx. So ours is going to be y equals 10 or 10.002, I guess, if you wanted to go out places, divided by the quantity 1 plus 2.37, I'll round to. That should be a 6, right? Boy, I need to go to rounding school. E to the power of negative 0.501 x. Now, it looks like I still have 3 variables. Do I have 3 variables? Do I have 3 variables, guys? I have a y and an x, but what is that e?
A number.
It is a number, yeah. Negative 0.501. Why is there a negative? Because it came with the formula down here, right? All right. If you're ever confused how to write it, where else could I look on my calculator? I'm not sure it's very helpful, but if you go to y equals, it does say 10 divided by 1.2 e to the, okay? It just has a million decimals in there. All right, if I graph it, it is hitting those very nicely. Make a conjecture about why a logistic model might fit the data. Oh, we're supposed to find the value at 20, sorry. I put my calculator in Ask Auto. Remember, it's second window. And I have Ask Auto because then I can just go here and type a 20 rather than scrolling around. How many mice are there after 20, whatever this is, months or years or something? Did it max out about 10? Why do we think this might fit? Okay. Why does it work for this kind of data? Yeah, a habitat can usually only support so many, right? A limited number of whatever species it is. In this case, mice. Okay. Any questions? All right. These are the kinds that we're supposed to be able to identify We've done linear and quadratic. Okay, power and exponential look very similar. I would tell you which one to use. Okay, they do both give you an R value. Logarithmic. Logarithmic is this shape, but logarithmic is ln reg on the calculator, just so you know. If it says to do logarithmic, it's ln. And logistic would be it goes up and flattens out. But logistic doesn't give you an R value. Okay. The exponential and logistic regression models appear to most accurately fit our data for this question. Okay. So we had, for this set of dots, these two, exponential or logistic, seem to be the best. Some models are better than others for predicting long-term behavior. Others can predict short-term behavior. Okay, this is what I talked about. There's ways to test all these. If you want to test which is the best, you would have to find the natural log of all the values. You would put them in a new list, plot them against each other, and figure out which one is linear. It is a long, painful, tedious process that we're not going to do. Deal? Okay, so I'm skipping all these slides. We're going to do this one real quick. Yes, I can do it if you don't want to type it in. I'll just do it on mine. You can write it down. The spread of a given computer virus is measured over time. What model best describes its growth? How many machines will be affected on day 9? Okay, so I put that data in. Tell me what I should do if I have that data in, guys. Stat, enter. It is in list 5 and 6. Does that look right? Okay. How do I look at it? Okay, I'm going to actually clear out the old one. And because it's in a different list, I have to go here and tell it to look at 5 and 6. But then the important thing is I have to find a new window, which is Zoom 9. Okay, did I get what it shows on your paper roughly? Okay, now it says what shape, well, it actually says the shape suggests a logarithmic function. Okay, back here on this slide, this is logarithmic, okay, and it is ln. It is a natural log that we're going to end up using. I have lost my place totally. Am I on this one? Okay. So I would go stat, right arrow, and it's ln regression number 9. And mine were in 5 and 6. Does that sound right, guys? And then this is what it looks like. Whoa, let me go back up here and save it. It's a plus b times the natural log of x. So a is a shift up or down, and b is a stretch of a logarithmic function. It does give us an R value, and it is a very good fit. It hits all the dots, right? So let me go back to there and put this on so we can write it down. So here's where I need that, not that page. So on the top of page 14, it says calculate the logarithmic regression. Can you make sure that you write yourself a note that that was ln reg? Okay. Oh, it says right there, this is ln reg on the calculator. All right, so we got y equals 614.37 plus b is 217.41 ln of x. Now they wrote it differently right here. but we're supposed to figure out on day 9. So tell me how I would do that since I have it saved. Yeah, I can go to the table and I have mine on Ask Auto, or you could just trace. I'm going to put in a 9, and I have about 1,092 computers are infected. Okay, if I go back to the chart of values, does day 9, 1,092 fit right in there? Okay. All right. Can you do this one? Because this one doesn't give us a model we're supposed to pick. Now, I don't think I have this one typed in. Is it 20 through 80? All right. I am going to go ahead and put mine in. I'll do override 3 and 4, I guess, because they weren't too bad to type in. Did I say 20? Did it start with 20? By tens? Up to what? Okay. And then, oh, lovely. 18.36, 8.16. This is the brightness of a light measured from different values. So as we get further away from the light source, the brightness gets less, right? So if we think about that, some kind of a decay maybe? Did I just put the same number in twice? No, 2.94, okay. 2.04, 1.5, and 1.15. Okay, I'm not real convinced I have those in right. List 3 and 4, I put mine in. Does that sound right, guys? Okay, everybody, before I do it, can you tell me? Yeah, I got it. Can you tell me what you do to see it? Set up your stat plot, but then you have to do a zoom 9, okay? Does yours look like that? Okay. Definitely some kind of decay. What do you think? Well, I'm going to go back. We started out with these choices this morning. Exponential decay, logarithmic decay. I think they're kind of the same shape, aren't they? Just slid around on the screen. I don't think it can ever become negative though, right? It says here the difference is 1 is never negative. So if I go back here and we call this exponential decay, what will happen is I'm going to pick exponential, stat, right arrow, and exponential regression. I think this will work. Sound so confident, don't I? 3 and 4, guys, is that where mine were? Second trace, enter. All right. How do I know it came out a decay function? What's the growth rate here? Yes, the B value is less than 1. Okay? So I have 33 points, and we can look at the graph before I put this away. Okay? So, put this on my screen. The scatter plot we were supposed to draw. I don't remember. Was it just doing this, guys? And then it says create the exponential or logarithmic model. So we're going to write 33.15 times b, which is 0.956 to the x. I don't know, I'm picking random numbers of decimal places now, sorry. So if I asked you the rate, which I didn't, it's going down by what, 4% roughly? If I did 1 minus 0.956, anybody do that for me? Is it 0.044? So it's going down by about 4.4% with every meter. Is that what it was? So we're supposed to estimate the brightness at 100 meters. So if we were to go out 100 meters away, I'm not thinking we're going to get good light, are you? I got 0.38 candela, yes? It is a unit of light, like a candle. Brightness in candelas. I believe a candela is like the brightness from one candle 1 foot away or something. I don't know, it's a weird definition. All right, so this is what you guys have to do. You want to grab worksheet 4, flip it over to 14B. Circle number 2, but you can cross off part B, okay? You need to do number 2, but you can cross off part B. And then you need to do number 3, which might be on that, is that on that page as well? Does it that one doesn't tell you to do a test, does it? Tells you exactly what to do. Okay, then on page 15, you need you need to do 4 and 5. Can you circle 4 and 5 on 15? Does it say to do a test? Yes. You can cross off if there's any testing. And then on 15B, the only one you need to do is number 9. On 15B, please do number 9 because that is on the quiz. On 14B, 2 and 3. 2 and 3, but on 2, you don't have to do B. 2 and 3, then 4 and 5 and 9. Everybody good? All right. I'm going to go back. I would like you to come back and do these with me because these are both quiz questions. These were my warm-ups that you don't have. So can anybody talk me through this casserole question? 325 is what? Is the original temperature, right? When it comes out of the oven, it's the same temperature as the oven. Okay? It cools to 200, so that is the final temperature momentarily. After 14 minutes, that's a time. In a room that's 68, T sub S or T sub M. Okay, it's the surroundings or the medium. I think it's an M on your actual quiz. So now we got to put those numbers in. We don't use this number yet. Why not? We have to find K first. So the final temperature was 200 when the room was 68. You guys be doing some subtraction for me here. The original temperature was 325 when the room was 68. E to the negative K times 14 minutes. Okay, so you subtract there and get, anybody helping me? 132. And over here we subtracted and got? 257. And negative K times 14, I'm just writing negative 14K. All right, so some people weren't here yesterday. What's the next step? Yes, so we're going to have 132 over 257 equals e to the negative 14k. We're isolating the expression that has the variable k. Then what do we do when we have an e? Natural log of both sides. So on the left, we're going to get some messiness, ln of 132 over 257. You guys be typing that for me. And on the right, we have negative 14k come out in front of natural log of e, which is just 1. So then we got to divide by negative 14 to get the k value. And it should be a small positive decimal. What did you get? Everybody agreeing? Okay. Now, we have to repeat this whole crazy process, remember? Putting in that we want our new final temperature to cool to 100. So our new final is 100. Our original is still 325. K is now 0.0476. The temperature of the room is still 68. But what are we looking for this time? Time. This time we're looking for time. Okay. I have almost no room left. Okay. Let's see, it would be 100 minus 68 equals 325 minus 68. E to the negative 0.0476t. Okay, 100 minus 68 is 32, is that right? Yes? And over here, this was 257 still, right? Okay, so if I divide 32 over 257, oh, that's a 7, clearly. Then I'm going to take the natural log of that. Negative 0.0476t ln of e, which is 1. Okay, so then I have to divide that by negative 0.0476.
Oh, that looks fun.
Just typing? What'd you get, Destiny?
43.74.
So 43.7 minutes roughly? All right. This, I would really suggest, maybe I can make this print a little better, smaller so that it fits. Well, let's read it first. I would suggest you maybe take a picture of this one afterwards, or you write it down as we go, because this is the kind of question that's on the quiz, and it gets complicated at the end. It says, create an equation to solve this application problem, then find the length of time needed. A single-celled amoeba reproduces every 6 hours by doubling. If 100 such amoeba are placed in a petri dish, calculate the amount of time to the nearest tenth of an hour needed for the population to grow over 10,000 amoeba. After rounding to the nearest tenth, find the actual number of amoeba over 10,000 that will be present. Okay, kind of complicated, but this is what's on the quiz. What is, yes, it is the half-life / doubling formula. Good job. So the number of amoeba in the dish is equal to the original, which is, and what is the rate we're supposed to use? Not half this time.
Doubles every 6 hours.
So 2. And how do we say every 6 hours? Instead of the half-life being 6, the doubling time is 6. So this is t over 6. In other words, it won't double until it gets to 6. If I put a 6 in there right now, I'd get 6 over 6, or one time it's going to double, right? If I put a 12 in there, I'd get 12 over 6, or twice it's going to double. Does that make sense? Okay. Now what are we supposed to do? Figure out how long until it gets to 10,000. Okay, guys. What is the number one mistake we don't want to do? We don't want to do 100 times 2, right? We're going to divide both sides by 100. What's 10,000 divided by 100, guys? 100, isn't it? Equals 2 to the t over 6. Then what? T is in the variable, so I have to do log of both sides. I'm going to do base 10, because I can actually do part of that in my head then. It's 2 to the t over 6, so this can come out in front. So I have the log of 100 equals t over 6 times the log of 2. Now, I can divide by the log of 2 to get rid of that. So I have t over 6 equals, can someone tell me what that is? 39.863. And before multiplying by the 6? Or, okay, what was it before you multiplied by the 6?
6.643.
6.643. And then to get rid of this 6, we had to multiply by 6. And then it says round to the nearest tenth. So what did you get?
39.86.
So that would round to 39.9. Now, this needs, we got to talk about this. This is getting bigger, right? The number of amoeba are getting bigger in the dish, the number of them. So we want it to go over 10,000. Did we round this up? Because it has to round up. We did. Okay. So now this is the amount of time to the nearest tenth of an hour, 39.9 hours. How are we going to figure out how many extra amoeba we ended up with? Yeah, let's just put it back in. 100 times 2 to the 39.9 over 6. Can you do that? 100 times 2 to the power of 39.9 divided by 6. Did we end up with extra amoebas? If we didn't get over 10,000, well, then you would have to go back and round differently. This is how many, so the question doesn't ask that, though. What does the question actually ask? How many over 10,000 to the nearest amoeba? So we wound up with, wasn't it 43? That's supposed to be a 4. 43 extras. Okay? There's a question like that on the quiz. We will practice some more tomorrow. But that was something that you should have been doing last night. So I hope you did last night's homework.